guys, we're here for the continental drift.
So the guy who came up with continental drift, his name was Alfred Wegener. He was born November 1st of 1880 and died in November of 1930. He came up with the idea of continental drift.
Okay, so continental drift is normally is said as like the continents moved back and forth. So his first idea was Pangea, and so this meant all Earth, and so all the Earth was together.
So this started during the Jurassic period, and the Jurassic period began 251 BC, and that occurred 199 million years ago.
So he also wrote a book in 1915 called The Origins of the Continents and Oceans.
And Alexander L. revised his hypothesis, adding Laurasia Gondwana.
Okay, so I am for the continental drift. So my first piece of evidence I have is Pangea. I'm sure you guys have all seen Pangea, but Alfred Wegener came up with the idea of Pangea, but he wasn't the only one that studied it. Alexander L. du Toit revised Alfred's hypothesis and came up with the other two continents when they were slowly starting to spread apart, named Laurasia and Gondwana. As you can see in this map, you can see like the time different periods. So it starts in the Permian time period, but then slowly continues through to where we are currently today. The continents move about 2.5 or about 1 inch a year. So eventually someday we will all come back together. Okay, so for my second point for the continental drift is the evidence that shows through the fossils and the animals that eventually lived on these planets when they were connected for Pangea. You can see through not only that, but also the weather trends that kind of come. So like if it was tropical, then it was normally connected with like a tropical place. So like the tip of South America and Africa. Yes, they're kind of both dry and deserty places. They're both warm, so they're kind of connected. So as you can see in the picture that I'll attach at the end, there are animals. There's 4 that we're going to study, but there's so many more. Okay, so the first one is this freshwater reptile. It was on the tip of Africa and then also on the tip of South America, and so then that's what made scientists believe the fossils were found on both, so they had to be connected at some point because these animals don't really move. The second one is, we're going to talk about 2 land reptiles, but the first one was in the it's called the, I don't even know, but it was in the Jurassic time period. It was connected all the way through Africa, India, and then some of Antarctica, which were all connected, so that's how they believe. And then there's a fern that went through all of them, so South America, Africa, Antarctica, India, and Australia. And then the last one we have is a reptile, and it was also in Africa, India, and Antarctica. So that just shows some of the examples that scientists have used to determine that the planets were all together because of the animals and the fossils that were on the land. Okay, my third piece of evidence for the continental drift is the tectonic plates. Most of you guys have known that tectonic plates cover our Earth and they're everywhere. They cause earthquakes and all kinds of bad things, but they also cause the lands to move. The plates move, that causes the earthquakes and everything else. So one of the theory behind this is that the tectonic plates are always moving. So that's a reason why we were together at one point and now we're far apart, and that we're slowly moving back together is because of those plates moving a little bit.
In the early 20th century, the thoughts on how the mountain belts and the sea depths were formed and is what made the theory that Earth was a modern blob and gradually cooled. When the Earth cooled, the heavier metals such as iron sank to the bottom, which formed the core, and then the lighter metals like aluminum stayed up more in the crust. Cooling also caused contractions and pressure, making the crust buckle upwards to form the mountains. The other parts buckled down to form the ocean basins. Another theory was called geosynclines. Having the theory of continental drift is what brought up this thought, and the theory was used to explain how continents, sedimentary layers, and mountains were formed. This theory became so popular that it almost weighed out the Pangea theory. Another theory was uniformitarianism. This is another theory that came about from the continental drift theory. Some more explanation on this theory is that it is the slow, uniform geological process that was firmly believed upon in the science community. This theory was used to debunk Pangea because continental drift was said to have been a rapid and recent massive movement, so therefore leaving the continental drift theory to have to slightly change its name to plate tectonics to remove the rapid, fast part of its definition.